Hello, everyone. Welcome to another Tech Talk of Mirantis Labs. Good morning, good afternoon, good evening, wherever you are or from. Thanks for joining. I'm Avinash Desireddy. I'll be the host and also the presenter for this webinar. What we do at Mirantis is we bring in different cloud native topics to the end users, and Mirantis offers a bunch of cloud native solutions with managed Kubernetes, the solution registry, the Lens desktop, which improves the developer experience, etc. So just doing a deep dive into the webinar. So here is a quick disclaimer that I need to present it. So all the content that is shared here is mainly for informational purposes and to educate you all. I'm Avinash Desireddy, Senior Solutions Architect and a developer advocate here at Mirantis, and I do everything Kubernetes, like helping customers, like educating developers on cloud native topics, working with large enterprises in terms of containerizing their applications, modernizing them, building Kubernetes clusters, operationalizing them, implementing DevOps processes, everything around like cloud native. I do work on them. And few housekeeping items here. The Q&A panel is enabled. Please feel free to use the Q&A panel to post the questions throughout the session. And I will be looking into these questions from time to time, and then I'll try to address everything in this call. If there are any additional questions, I'll be sharing them in a follow-up email as well. And I'll be providing the links to download the slides as well as access to the recording in a follow-up email after the session. So with that, here is a quick agenda. We are going to quickly look at Kubernetes architecture and user request workflow. Then deep dive into authentication and authorization concepts in Kubernetes. And I have like a short demo on authorization, how exactly it works, how it needs to be implemented in a Kubernetes cluster. So with that, let's dive into the Kubernetes architecture. The Kubernetes architecture consists of like two sets of nodes, control plane nodes and worker nodes. Worker nodes, or like all these nodes, are also referred to as machines. Each node can be on its own physical machine or on a virtual machine. So that's in terms of the nodes, how they are like categorized. The control plane machine components include like API server, scheduler, controller manager, cloud controller manager, cluster DNS, and etcd, which is a data store. And mainly on the worker node, like the key components are container runtime, kubelet, and kubeproxy. So an API server like tracks the state of the cluster components. So it is the primary component which accepts the user requests and then performs operations accordingly. In addition to capturing the user requests and then submitting to the cluster, it also tracks the state of the cluster components and manage interactions between them. And the next key component is scheduler, which distributes unscheduled workloads across the available worker nodes in the cluster. And we have the controller manager runs all built-in controllers, like for example, node or a replication controller. For example, if an application or if certain pods go down in the worker node, the replication controller, which is a built-in controller in the controller manager component, will take the responsibility of ensuring the number of pods meet the desired state. And the cloud controller manager is an extension for the controller manager, where it is specifically designed for the cloud environments when we have to manage resources in the cloud. For example, if we have to auto scale the cluster by adding more number of nodes, or create load balancers dynamically, or manage DNS entries that needs to be assigned for that needs to be mapped to applications, they can be automatically controlled using the Cloud Controller Manager. And we have the cluster DNS, which provides an in-cluster DNS for pods and services. So the pods can communicate with each other using a friendly name, or like to a service, or even they can uh, discover the the respective IP addresses, or like find the external components using a friendly DNS name. And the other key component is etcd. So all these components have worked together, but where do they store all the data? Because they need to store the data in some data store. So the data store here is etcd. It's a key value store that stores all the configuration data that belongs to the cluster. And we just talked about the API server. Next, we have on the worker node, there are like three key components. First one is the container runtime. So what container runtime does is it implements the CRI, like containerd or cryo, or it used to be initially it used to be like implement Docker as well. So the container runtime will ensure the kubelet uh, interacts with the container runtime and make sure it controls the container lifecycle essentially. And the kubelet, what it does is the worker node has to talk to the manager or controller node. So kubelet takes the responsibility to interact with the API server and manages all the containers on the respective nodes using the CRI. And then kube proxy. So now we have kubelet helps in terms of scheduling all these pods or like executes all these containers on these worker nodes, but they need to interact with the node. So the networking layer within the node is handled by the kube proxy, where it accepts and controls the network connections to the node pods only within the node. So here, this is like about what like the basic components does. Now, just diving deep into the architecture. So I mentioned earlier, like all the requests will go through the API server, because that's one of the key component that accepts user requests and controls different components in the cluster. So how does a user interact with the API server? The user can interact with an API server using a kubelet or a UI-based application like called Lens Desktop. What the UI-based applications or kubelet does is they implement the REST wrappers that the API server exposes. A user access the API server like using the kubectl command. And in the demo, while in order to create certain pods or certain resources in the cluster, we'll be looking into both kubectl as well as the Lens Desktop in terms of how these operations are performed. And when it comes to the users, there are like both human users as well as Kubernetes service accounts who will be accessing the cluster directly from the API server. When a request reaches the API server, it goes through different stages like authentication, authorization, and admission controller. So first step, like the user input to the authentication step is a HTTP request where the authentication module will examine the headers and the client certificate of the incoming request. And only if it is authenticated, only if the user is authenticated, then the request is accepted and then further passed on to step 2 for validation. If the request is not validated, or if the request gets denied, in this case not authenticated, it's get rejected, and a HTTP code of 401 is sent back to the client. And we'll take a deep dive into how authentication is implemented and what are like the authentication backends in next few slides. The second key step, or like second stage, is authorization. Once the request is authenticated as coming from a specific user, the request must be authorized. We will look into how this authorization works in detail in a bit. If a user is not authorized by default, like the default configuration is the user will have like very limited access and it's a default deny all. So if the user is not authorized to access any resources in the cluster, the request gets denied. And let's say if the request gets accepted, then from the authorization stage, the request will be passed on to the admission controller step. In admission controller, what it does is it's a piece of code, like it intercepts the request that it received, and it manages the request. For example, if we have to make any changes in the incoming request in terms of adding certain node labels or attaching secrets or certain changes if needs to be done on the incoming request, that can be done in the phase of admission controller. Now, from these three steps, we will be talking more about authentication and authorization next. And admission controller is a bit of a scope for this session, and we'll be having a follow-up session to discuss more about admission controller, because it is also one of the critical component in how a request gets how an application gets deployed in the cluster. So now let's deep dive into authentication. We know every request gets authenticated by the API server. Now, what authentication methods it supports? Like do we have to create username and password like within the Kubernetes API server, or does it look up for the username and password from a file or from an external database? What does it look like? That's what we'll be looking at. And for that, like let's understand the key objects. Kubernetes clusters have like two categories of users. I've like specified this earlier as well. Like one is the service accounts, which are managed by Kubernetes, and then the normal users. Now let's talk about like normal users. It is assumed that cluster independent service manages these normal users in many ways. That means a Kubernetes cluster does not have any object that represents a normal user. There is no database that is associated for these normal users. For example, if we need to create a user, we cannot create a user directly in a Kubernetes cluster, because it refers to the existing users, but there is no database associated with it. Like one example that we can relate to that is, for example, if we take a Linux machine, we can create any number of users in Linux machine using user add command. So whenever we can do a user add and add a new user to the cluster, and then we can do a user delete or user modify, we can make any number of changes. But that sort of functionality is not available in Kubernetes. Where does, in that case, where does it look for all these users? So that is where the integration or the user store, like the existing user stores, are utilized. For example, LDAP or Google Cloud IAM or Amazon IAM. Like there are like different identity providers where the user credentials are stored. And in case of Linux, like the default is like in a file or in a password store. So so it uses a lot of these external systems that are already like far matured in terms of uh, managing users, and then Kubernetes just refers to specific attributes within these different systems where they are mapped according to the Kubernetes specification, and also according to Kubernetes specification to provide further authentication. And so that is like with respect to the normal users. And with respect to the service accounts, Kubernetes, they are like native to Kubernetes cluster. Like it's a resource, a Kubernetes resource object created and managed using Kubernetes API. Like the reason they are created and managed within the Kubernetes cluster is they are meant to be used in cluster. In cluster, that means like a pod to authenticate to the Kubernetes API server or external services uses the service account. Kubernetes service accounts lets you give identity to your pods. So using this particular identity, a pod can request more information or like interact with different pods or like to the API server. Like one of the best example for the service accounts is like they used to authenticate pods using Kube API server, allowing pods to read and manipulate Kubernetes API. For example, like in CI/CD pipelines to deploy applications into a specific cluster, we create a service account because we don't want a human user account to be part of our automated process automated process where we plug in all our details. Instead, we will be creating a service account that can be managed and implemented by that can be injected or used in our automated process. So we talked about like different types of users, and also like Kubernetes does not have a default like data store to store these usernames and passwords. So here are like the methods or the strategies in which strategies in terms of how API server will look up different systems for the user information so that it can authenticate. So what happens is like whenever a user runs a kubectl command, like either they can be a developer or an administrator, or it can be a service account. It all starts with kubectl, where the request gets converted into a HTTP request by the kubectl. And also we can interact with API server without like directly using this HTTP request, like with the help of curl or any other client libraries, which where we can send this HTTP request out with the appropriate headers. Kubernetes uses like the client certificates, like static tokens or like password files, like bearer tokens. It also supports like OpenID Connect tokens, like webhook token authentication, authentication proxy, anonymous request, and user impersonation. So these are all like the different strategies or like the methods API server uses to authenticate a user. So we can use just one strategy or multiple strategies together in order to validate the users. For example, in our organization, we have two different systems. Like one is, let's say, Okta, and then the second one we have is a traditional, like very old system where the users needs to be authenticated using a username and password, which is a custom built system within our organization. So we can tell the API server to authenticate against these two systems uh, at the same time. So if the user is not found or in one of the system, then the second method is used to validate if the user is authenticated or not. And we'll be not going in detail into each and every step, but based on like the namings, some of them like provide are like self-explanatory. Like for example, like static token or password file, what it refers to is having a user token or like a file with username and password information stored and accessible to API server using API server configuration file, will let any user defined in this specific password file or like static token file, uh, the user can get authenticated automatically. And also like in terms of like the webhook authentication, like this is like if there is a custom system within the organization, so whenever a user wants to authenticate, the request can be sent to this external system where the user gets authenticated, and then a token will be generated and further given back to the API server uh, for further processing. And so looking at all these different systems, you might be thinking, how can we implement all these things? What is the right approach, or which one we should be using, etc. But we don't have to think a lot in terms of implementing which system. For example, like maintaining a password file, which is a text file in the system, is uh, is not at all a recommended approach. And I think even like that option is being deprecated in the latest versions of in the latest releases as well. And in order to keep it like more secured, the complexity of integrating with the authentication backends is simplified by the managed Kubernetes providers. Like for example, in Mirantis Kubernetes engine, there is a support for SAML integration, or an LDAP backend, or like there is a default authentication database where the authentication details are stored in the backend database called etcd. And I will be showing quickly in terms of how to create the user and where it stores, etc. In the demo. The next one, like if we take Google Kubernetes engine, it manages end users authentication through Google Cloud CLI, where the Cloud CLI is tightly integrated with Google Cloud IAM. That means our GKE cluster is being integrated with Cloud IAM. So we have this single sign-on mechanism to access any of these Google services or the Google Kubernetes engine using a single point framework. And similarly, in Amazon EKS, it uses IAM to do the necessary integration. So this covers the authentication part in terms of quickly summarizing like the complexity, like the different methods, etc. Let me quickly look through the chat window to see if there are any questions. Please do feel free to post any questions in the Q&A section. Okay, what about so there's one question from Don. So the question is like, what about integrations with Azure AD or Azure B2C? Yes, even for example, if you have deployed a Kubernetes cluster like from an open source distribution, or if you are using Azure AKS, the Azure AKS by default integrates with the Azure authentication components like Azure Active Directory. There is an option to integrate uh, to enable this integration seamlessly while we are spinning up the AKS cluster using the portal. I've not listed on all the providers here, but like there are like multiple service providers who can integrate, who supports this level of integration. Okay, so there's one more question from Deepak in the chat. How Kubernetes integrates with Azure AD, how access is given to a particular namespace. So what we have talked about is in terms of like granting user access, and mainly in terms of integrating how Kubernetes integrates with Azure AD is by following. So it falls under the OpenID Connect tokens, where we have to do like some configurations under API server to support the external system configurations. For example, I can show in MKE, which is Mirantis Kubernetes engine, how it is done. So let me quickly show here. So I'm accessing the Mirantis Kubernetes engine. So similarly, you will have a similar set of configurations uh, in the respective managed services as well. For example, if I go to the configurations in Mirantis Kubernetes engine, there is an option here, authentication and authorization. And if I just scroll down, there is an option to integrate LDAP. So whenever we select this option, it gives a lab server, and we have an option to provide all the necessary details to do the integration, which is the same with Azure Active Directory. If we have Azure Active Directory, we have the directory address, and then there will be a secured account to connect to this particular directory, and also we'll have options on like which domain in which domain we need to look up for the users, etc. All these configurations can be configured in based on the type of environment that you are using. But each cloud provider or each managed service provides seamless integration to their own services. For example, GKE provides seamless integration to Google Cloud IAM. Amazon, like EKS, provides seamless integration to the Amazon IAM. Like similarly, like Azure AKS provides seamless integration to Azure AD. So different systems like provide seamless integration to their identity systems. So we need to look into that specific documentations for configuring the identity providers. And all these different systems, like they don't limit in terms of supporting or using only one backend. There will be support for multiple backends as well. So we cannot like limit ourselves directly that what is that directly that like GKE supports only cloud IAM, but there is an option like where you can integrate GKE with Azure AD backend also, provided all the network connectivity is supported. Okay, hope that helps. Like one more question from Deepak. Suppose we have authentication enabled via Azure AD to EKS. Is there a way to figure out what all users have access to which namespace with what all roles? Yes, we do have ability to look at that information, mainly in terms of how a namespace will get access to it. We'll look into it. I will discuss that further in the authorization section. So we'll get into the authorization section and hope that helps. If not, please post please post a follow-up question, and then we can deep dive into that functionality. Okay, I will take it to full screen. Okay, now we'll get into the authorization. So now the user is authenticated. So we finished like the step one in the API server. Now, once the user is authenticated, we need to know where or what the user is authorized to. That means what can they do. I usually take this as an analogy, like of an airport where we wanted to fly to a certain destination. So our step one is we need to get into an airport. So that's like an authentication phase. In order to get into the airport and clear the security, we need to have a valid flight ticket and an identity to pass to the security. So that's like the step one of authentication. And now once we are in the airport, we have to fly to a certain destination. Now, that's where the authorization comes in. Which flight can we take? Can we take any flight that is in the airport? No, we cannot. We are allowed to take only certain flight. So here in this case, like the user should have access only to certain objects in Kubernetes, like for example, a specific namespace. And even inside the namespace, they should have access only to a specific pods or secrets or deployments. So that level of control is in the Kubernetes is set using the authorization model. And there are like different authorization models that Kubernetes supports. Some of them they are mainly like role-based access model, which is the popular method that we will be deep diving into. And there are like other methods like attribute-based role-based access, attribute-based access control, the node authorization, and webhook. So mainly what role-based access control method does is it regulates access to the resources based on the roles of individual users. In this context, like the access is an ability for an user to perform specific tasks such as view, create, or modify. So similarly, like a user like enters into the airport, now uh, the authorization, like what can he do, like which airlines he has access to, like which specific terminal he has access to, and can he take a specific flight or not. So that can be defined using this method. So the other one is the attribute based access control. It's where the users are given access using the policies and combining the attributes together. So this is like not a well-known approach, at least like with my experience, like working with multiple Kubernetes environments and with multiple customers. Uh, Attribute-based access control is not very popular. I have not seen anyone implementing this. And node, and then the next one is like the node authorization. So it's a special purpose authorization mode that grants permissions to kubelets based on the pods they are scheduled to run on. And then the next one we have is webhook mode. A webhook is is a HTTP callback. For example, if you don't want to use the default RBAC model or any of these models, but you have your own external system in an organization, and you want to validate if a user is authorized or not based on the custom model that you have come up with in your organization. So we can use webhook mode to integrate the authorization system into that, where every time the system, the API server needs to do the authorization, it will fire a webhook call and wait for the response. Once it receives the response from the target system, uh, based on um, based on the rules that it specified in the system, it will allow the request to access specific resources or not. So, so we just like talked about what it is. Now, let me like put this in a scenario uh, where there are like three application teams and then three users who belong to these application teams, like blue, green, and red. And we will, I'll go through the scenario of how a specific user can be granted access to a specific namespace. In this case, like blue user, I'll be giving access to a blue namespace, green user to a green namespace, and red user to a red namespace. So we'll go through that in detail. So before that, let's understand like the terminology around like role-based access control in Kubernetes. So first of all, like in order to in general, in a role-based access control model, a role represents like what action can be performed on a set of resources. So in this case, like resources are namespaces like network policy, pod, services, anything, any like type of object in the target cluster is referred to as resources. And the action is referred to as verbs. So action is what can we do? Can we list the resources? Like in this case, like namespace, can a user list the namespace or list these pods that are running in a namespace or list services, list custom resource definition. So uh, all or it's not just listing them, like get, watch, create, like all different type of actions that you are seeing are referred to as verbs. For example, like we can define a role just to create a namespace, nothing else. Or let's say uh, in this case, I'm creating a role named role blue. It is created in blue namespace. Is only allowed to create, delete, and list deployments and services. Nothing other than that. Creation of any other objects like cron jobs, daemon sets are not allowed, because as soon as because this role defines or defines like whoever is assigned to this role, they can do only operations, only certain operations on certain resources. A role is active. Like right now, we define just the role, which maps the actions, what actions can be performed on what resources. But we have not mapped it to users. So how we can map it to users is using a role binding mechanism. A role is active only when it is attached to users, groups, or a service account. So they can get permissions defined in a role. Users, groups, and service accounts, in terms of Kubernetes, they are referred to as subjects. So that's the reason, like if you look at this YAML specification, you see a subject, and under subject, there is like an API group, and under API group, like we have this kind user, and the user we are referring to here is blue. So the blue user cannot perform any other operation in the cluster, because we are saying the blue user is assigned with this role blue, and he can perform only the operations that are defined in here. The similar setup can be done for like the blue and green users. So I'll be showing them in a bit. And with that, like let's jump into a demo where I'll walk you through the code samples in order to create the namespaces, delete, and then create roles and map those roles with specific users. Okay, so here in the code base, like what I'm doing here is so step one is creating a namespace, and once the namespace is created, we have access. So here are like the specifications that we are giving for the role blue. Like in the template, like I've like listed just like deployment services and pods, but here like I'm just adding like few more resources which which will be managed by this particular role within this particular namespace. And the role binding, so here is like the same code snippet that we are seeing here. So step one for me is to create these users and make sure they are attached with a specific backend. So I have done this earlier, like where if we go into the user section in the Mirantis Kubernetes engine, so I'm using Mirantis Kubernetes engine as my Kubernetes distribution for this demo here. And I've created 3 different users, blue, green, and red. And I've generated the kube config file so that the users can interact with the cluster. And I'm going to access the cluster using lens. So lens is just a fancy way of like running a kubectl, where if I run, let me increase the size of this as well. Get nodes, it's going to give me the list of nodes that are connected to this particular cluster. I wanted to set up this particular blue user, so I'm going to just type kubectl apply -f setup blue user. So as soon as I set up blue user, it will create the respective resources. I do have the namespace created already. That's why it skipped in the create option. But if you see the role and in the role binding, they are created. Now, once I have created this, I'm going to switch to the role blue user, and we are going to see what the role blue user can do. So the MB is this cluster's blue users context, and I went here. Looks like only blue user can access this particular blue. What is that? Like the objects in the blue namespace. I will also go through the same thing from the terminal. So to simplify, showcasing how it can be restricted. So I'm going to switch. I'm going to switch the context to green user. And now what we'll be doing is using green user, we will try to access the resources created under blue namespace. Get pods -n blue. The reason we should get a denial message because green user does not have access to the resources under blue namespace. What about listing the namespaces? kubectl get namespace. The user even cannot get the namespaces because we have not configured any permissions for this particular user. So as a next step, what I'm going to do is I'm going to set up the green user as well. -f setup green user. So what this does is it configured the green namespace and it created the role for green user and then the role binding. So if we do kubectl get pods -n green, it can list pods because green user has access to green namespace. And like the reason it is not displaying any pods is it does not have any resources in there. If I'm gonna you using the same user. If I just try to access blue namespace, then it will give access denied. All these commands I was running using user green. What if I switch to user blue? So I'm just going to change my context to blue user, and now blue user will try to get the parts from green namespace. And it should be access denied because the blue user has access only to access parts in blue namespace, nothing other than that in the cluster. So now we can see the user successfully got access to it. How this is done is, I'm just going to do another quick summary of the configuration file or like the setup files to do these authorizations. So initially, like we have this namespace, like either it can be created as part of the setup or it has already been created. For authorization, so initially we have this role, and this role has mapping to API groups, resources, and then resource and then the verbs. So all these resources will belong to any of these API groups that are listed here. And in this case, like the the users who have this particular role blue will can list the deployments, services, pods, endpoints, and only the operations that are specified here. And they can perform only these operations on these resources that are listed. Now, how is user mapped to the role is using this specification. So what the specification does is we have the API version, kind, and metadata, and the name. So this is the name of the role binding that we are creating, and it is in the namespace below. So subjects refer to the name of the user. So subject refers to the groups, users, or service accounts. So in this case, we are saying the object, the name is of type user, and the username is blue. So what this blue name should refer to this particular role called role blue. For the sake of simplicity, I'm going to attach the blue role to green user as well, and let's see what it does. And once we have this, I'm going to set it up again, set up blue, and it's going to make some changes to the role binding. And what we have done here is the role blue is attached to role green as well, that for the user green as well. So when a user green tries to look at parts in blue namespace, they will have access to it because we updated the permissions. So let's see that. So I'm going to switch to green user because now green user should have access to the blue namespace as well. See, we can, like, I've switched to the green user. Now, when the green user tried to switch, look at parts under blue namespace, it was possible. So this is like the quick templating of like how the role-based access model is represented and managed, and all these YAML files can be in the version control systems or in our CI/CD workflows as part of the onboarding process. So with that, I will switch to the okay, with that, I'm just going to take a quick pause to see if there are any questions. Okay, no questions in the chat. I'm going to give a couple of more minutes for anyone to type in their questions. Deepak, hope this helps in terms of how you can restrict access to a specific namespace for the users. The user can be anywhere, like which can be coming from a static user file, or it can be a service account, or it can be from an external authentication provider like Azure AD or uh, Amazon, Amazon IAM or Google IAM, or any backend system that you integrate the cluster with. Okay, I'm going to see for one more minute to see if there are any additional questions. Okay. That's all I have for today. So okay, there is one more question. So let me take that, and then we'll get to the next slides and we wrap up. So in Azure AD, if we create a new user, how does it connect with role binding file and get required authorization? Request to please help understanding it. Okay, so whenever we create a user, the user is assigned with a user ID, or for example, in Azure AD, if we create a user, for example, in this MKE portal, I am creating this particular user over here, like using create option. Like this is how I created like the user green. Same thing in Azure AD, the user will be created and the user will be populated into your cluster. That's where the integration with the authentication system happens. And when after the integration happens, now the user can authenticate to the Kubernetes cluster. And the unique ID, for example, here I'm using green, blue, and red as my usernames. Similarly, in Azure AD, you have VCN, common name, which is represented as username, or the specific attribute that you use to say that's my unique user ID. So you will be using that user ID to represent here, like in your role binding. So you will be taking that user ID and then referring here and refer it here. If it is an Active Directory group, then you'll be seamlessly changing this user to group and then provide the group name. So that is how it connects from user to the authorization objects. So the reason first one, like once the user is integrated, I think probably this is where the disconnect is. The user needs to connect with a Kubernetes cluster. So this is the kubeconfig file. Whenever we type kubectl command, it looks at this kubeconfig file in order where the username and then the user details are added. So using this information, the user gets authenticated with the cluster. So whenever a user types a command, the information that is in the kubeconfig file is presented to the cluster, and that's where, and that has all the necessary authentication information about what is the username and what certificates it presents, etc., to the cluster. And that username is used to further grant access. So that username will be used when in this particular section, like in the subjects section, whenever we need to provide specific authorizations to it. Hope that helps, Deepak. If not, feel free to reach me out. I'll be sending out a follow-up email. Please feel free to reply to that email, and then I can help you out. And I can deep dive into it further, and then we can understand what you're trying to solve, and then I can help you further clarify any questions that you have. But hope that this helps. And yeah, we have only 2 more minutes. So if there are any questions, like feel free to like reply to the email that I sent out, or like feel free to reach out to me on Twitter, and I'll be happy to answer any of the questions that you might have. And with that, like here are let's wrap up. Like so, here are like the upcoming sessions. Like so, the Mirantis Labs goal is to bring in educational content to on the cloud native topics for everyone who is passionate about cloud native ecosystem and mainly Kubernetes. So then on Thursday we have a we have a tech talk on getting started with Kubernetes, getting started with GitHub security, where we always talk about how to secure Kubernetes, but what are like the best practices in terms of securing our code bases is what we'll get into during the session. And the next Tuesday, we'll be deep diving into the introduction to Helm, when to use Helm, and what value it brings into what value it brings into the ecosystem, and how to write a simple Helm package. So we'll be getting into that in detail. With that, like team Mirantis is hiring, and we do have like several positions that we are looking to fill. If you would love to join Team Mirantis, feel free to check out Mirantis careers page, and then drop in and then just drop in your resume, and we'll be happy to review it further. With that, thank you so much for taking time to attend the session. Looking forward to seeing you all in the future sessions. That's all I have for today. Have a good rest of your day. Thanks, everyone. Bye.